I'm here to talk to you about something crazy. The banking crisis has been off the hook, okay? And then they're talking about TikTok bans and all this other stuff. But what a lot of you don't know is that they have been ushering in an entire shift for the human race. We're talking about nanotech and biotech.
So if you could look inside that drop of saline, magnified by about 70,000, you will see billions and billions of tiny objects. Each of these objects that you see here is a robot with chassis and moving parts, a robot that can be programmed to do amazing things.
Altering Humanity, Humanity 2.0, is outlined by Ray Kurzweil, Bill Gates, and some of the leading tech titans in the world. See, we don't have to worry about them putting a chip inside of our head. Since before 2012, they've been developing nanotech that sense things in their ambient environment. They're so tiny you can't even see them. It started back in the 90s with Chris Pister out of UC Berkeley. And this technology, initially, they could only fit these sensors on like the size of a quarter or a 50-cent piece because of battery power. But eventually they got the power solution down to where they can draw power from their ambient environment, from a signal like 5G. And Intel built the operating system for this. It's called TinyOS. And what each dust node, so tiny you can't even see it, does is it senses the environment around it. Temperature, light, humidity, and the capabilities have gone way beyond that. But when you introduce trillions of sensors and then they're sending data, they're both they're receiving data from their ambient environment and they're transferring it and they're hopping it to the next dust node, to the next dust node, and then back to the host router that goes up to the satellite that goes down to the data mining facility. So follow me here. You have all these things collecting data from their ambient environment. And these tiny, tiny, tiny dust nodes have trillions of data points. And in order to network all of that and to process all of that data, there's no human that could process that amount of data over time. So we had to come up with a solution like artificial intelligence, data mining, and they are building a panopticon control grid that will require us to pretty much leave planet Earth to get away from. And it doesn't stop there, because they've begun to look at biological computing, DNA-based computing, computers made out of biological components. And as they get smaller and smaller, down to the, billionth of a meter level, down to the microns, the pores in your skin, we're actually porous. That's the reason why you can't handle certain chemicals. It can go through your skin. You got to wear gloves. They're working on getting this nanotech so small that they don't need to give you a shot. They don't need to give you an injection. All they need to do is release it into the environment. It can get inside you. Of course, they mean well with it, and they would never use it for nefarious reasons.
Very basic routine of pick cargo at A, drop cargo at B. We can build an astonishing array of tasks. And what I'd like to do now is to walk together with you through the tasks required to perform successful surgery. And let's see how each of these can be translated into the language that robots understand. So the first thing is that a surgery takes place at a specific interface. That is the interface between the target tissue and a background tissue. Now, a trained surgeon can manually define this interface with a precision of about maybe sub-millimeter. But these robots can do tens of thousands of times better. You can think of them as scalpels as sharp as a molecule, basically. So by programming robots to identify both target and background tissues, we can have them organizing themselves around that interface. And now they can expose and activate a cargo, which in this case is not a drug, it's an enzyme that can cut tissue components or matrix components, cut the links between cells, disintegrating the tissue cell by cell. The second thing that you have to know how to do to make a surgery is to move cells from A to B. You can either, in the most basic sense, remove a target, you remove your target tissue to the trash, in which case the trash is point B, or you can recruit cells from another place to come and fill in the gap and regrow and regenerate the tissue. So that's also moving cells from A to B. The robots know how to do this just like ants do when they carry prey much larger than themselves. They recognize the specific cells, as you can see here. They detach them from their surroundings. Then they can carry specifically those cells, not the other cells. They can carry them from point A to point B based on a combination of molecules defining points A and B, which is how the robots know to differentiate between points A and B. The second thing is, once you have the cell, you need to know how to reprogram its biology. You need to tell the cell to either die, or you can, again, recruit cells and tell them to regrow.
So, don't worry. They're working hard to keep all of us safe. And this whole grid just keeps closing in everywhere. There's nowhere where you'll be able to escape it. Anywhere where there is access to an electronic signal or you can send a field out, these sensors can send back the information. So, welcome to the new world where we're going to be living in some kind of Borg situation. Meanwhile, we're distracted with Donald Trump and Joe Biden and TikTok and Ukraine and all of this, and a major shift for humanity's coming. Lots of fun, guys. Lots of fun.